Hey everyone, welcome back to my channel. Today we're going to tackle a fun problem on LeetCode. It's called earliest finish time for land and water rides. And I'm excited to walk you through the solution. This problem is classified as easy, but it's a great example of how to approach problems that involve different combinations of events. So, let's dive in and explore the solution. The problem asks us to find the earliest finish time for land and water rides. We're given 4 arrays: land start time, land duration, water start time, and water duration. The goal is to find the minimum finish time by considering all possible combinations of land and water rides. So, let's think about the intuition behind this problem. Imagine you're at an amusement park, and you want to ride both a land ride and a water ride. You can either start with the land ride and then go to the water ride, or you can start with the water ride and then go to the land ride. The key insight here is that we can either start with a land ride or a water ride, and then switch to the other type of ride. This means we need to consider all possible combinations of land and water rides and calculate the finish time for each combination. Now that we have the intuition, let's walk through the solution. We need to iterate over all possible combinations of land and water rides. For each combination, we'll calculate the finish time by considering the maximum of the start time of the first ride and the end time of the second ride. We'll update the minimum finish time whenever we find a smaller finish time. This approach might seem a bit brute force, but it's actually the most straightforward way to solve this problem. Now, let's take a look at the C++ code that implements this solution. We start by initializing a variable min time to a very large value, which will store the minimum finish time. Then, we have 2 nested loops, one for land rides and one for water rides. For each combination, we calculate the finish time by taking the maximum of the land start time plus the land duration, and the water start time, and then adding the water duration. We update the min time variable whenever we find a smaller finish time. We do the same thing for the case where we start with a water ride and then go to a land ride. Now, let's talk about the time and space complexity of this solution. The time complexity is O(n)m, where n is the number of land rides and m is the number of water rides. This is because we iterate over all possible combinations of land and water rides, which is a nested loop of n and m iterations. The space complexity is O(1), which means the space used does not grow with the size of the input. This is because we only use a constant amount of space to store the minimum finish time, regardless of the size of the input arrays. And that's it. That's the solution to the earliest finish time for land and water rides problem. I hope you guys found this explanation helpful. If you have any questions or you'd like to share your own approach to this problem, please leave a comment below. Don't forget to like the video, subscribe, and comment your approach below.